AI. It's being called one of the most disruptive technologies we've ever seen. And honestly, it's hard to argue with that. It's a technology that's literally transforming every walk of life, causing people to rethink how we integrate information, analyze data, and yes, even change the way engineers design new products. The goal? Better efficiency, lower cost, and way more accuracy. But it doesn't stop there. What really makes it exciting and yet largely unknown is how it enables engineers to shift their focus from repetitive tasks to higher value, more impactful work. I'm your host, Raymond Yin, and joining me today is Nemanja Jokanovic, Head of Sales at SnapMagic. We're diving into how this powerful tech is turning the world of engineering design on its head. We'll discuss the good, the bad, and ultimately what it really means for the future of engineering. Nemanja, welcome to The Tech Between Us.
Thank you for having me, Ray.
To start us off, can you tell us a little bit about yourself and SnapMagic?
Yeah, I would love to. So, been in this industry, fantastic industry of ours, my entire career. Started early on in the advertising portion of this industry, still in print advertising and really working with component manufacturers and distributors on quarter pages, half-page ads, traveling all over the country and meeting a lot of people, which I've actually realized how incredible of an industry and small of an industry we are and well-connected. It really inspired me to learn every aspect of the business, which really led me into distribution and working in the digital space for a couple of key distributors in the business. And post that, really spending last 5 years as the head of enterprise, and one of the key members of the enterprise organization at Altium, serving customers and partners globally and helping them design products better. Today, I'm so proud and excited to be the head of sales for SnapMagic, and SnapMagic really being at the forefront of AI and electronic design and making the lives of engineers easier by enabling them to design products faster, more effectively, and at the same time enabling component manufacturers and our partners to communicate with those engineers. So all in all, very grateful for the opportunity just to be a part of the industry, learn about the industry, and make a lot of friendships along the road.
Oh, yeah. Like you say, for a large industry, it is very small. And I know you and I have known each other for a little while, and I know you've known people at Mouser for quite a while as well.
Yeah, exactly. I mean, Mouser has always been core for me, and made a lot of friendships and worked with a lot of people from Mouser, including yourself, on a lot of fantastic projects throughout the years. But for me, the special bond we have with Mouser today is really understanding the key aspect of the business, right? Really going from marketing department to the internet business of Mouser, and how Mouser influences the design and how Mouser enables people to get their products faster and into the hands of such engineers effectively. So for me, I was always fascinated how incredible of a marketing machine Mouser was. So learned from a lot of people from the industry who are a part of the Mouser organization. And, for that, I'll always be grateful.
That's terrific. And likewise, we've done some great work together.
Yes, indeed.
Absolutely. So, Nemanja, let's start by taking a look at the history of design tools and specifically CAD tools. Like you said, you've been doing this for quite a while. Where would you start with this whole discussion? At what point?
It's interesting because when you think about electronic design, and probably you witnessed that throughout your career being an engineer yourself.
Yep.
I mean, do you remember kind of looking at those pictures and tables of people rolling out big tapes with rulers, right? And introduction of really CAD. I mean, you can really refer back to the Industrial Revolution.
Going back that far?
I mean, if we want to, right?
Absolutely.
But to me, you think about the revolution, especially in the mechanical space at the time, which at the time was the core competency of a product life cycle. Was really starting with improving the efficiency of how design itself work on the CAD side and rolling out the big papers and then kind of leading us throughout multiple different generations of of CAD itself, right? Going from that into initial software, which we were all a part of, and birth of some of the major organizations today, from CAD and then into electronic CAD as well.
Yeah, I mean, I remember when I first started designing, I'm using an old system called PCAD. I'm not sure if you remember PCAD. And then after that, it was PADS and OrCAD. So yeah, we've seen this evolution over, the decades of, like you said, I mean, my very first senior design project in school was using tape and Mylar.
I mean, you referred to some of the key players there,
Yep.
right? And when you really think about, your Autodesks of the world and Cadences of the world, I mean, you can just see how far we've gone from the initial desktop software into today, cloud-enabled applications and design processes. But I do think it's kind of interesting and important to spend a little bit of a time on kind of what that looked like, right? Because if you go back to the birth of internet, right, really, and using the desktop where you would, get your license, install it on your machine, and really start working.
Yep.
It's just interesting to me how efficient at a time that was and how far out we've gone from the birth of internet and then into the, again, I would say industrial revolution of its own, again, through the birth of IoT. The devices started communicating, right? I mean, from industrial and factory applications to big trend being home automation, and obviously today stepping into the world of AI. But the process, I think the sweetest kind of era of that IoT growth, it was just scratching the surface of where our industry is headed and how capable we are as people in general, and how software is going to continue to evolve.
I mean, like you said, yeah, there have been, from the early days of CAD, we've added features, we've added, capabilities. But like you said, really, when things went cloud enabled and to enable IoT type devices, that's where really things really started taking off in terms of, being able to put together large groups with systems like this.
Yeah, I mean, think about just going back, not that long ago. You think about, and I'll use an automotive example here, but
Sure.
you think about the core competency of a vehicle was not necessarily the electronic capability. You
Right.
think about kind of that value that when you buying a vehicle, you're really looking at at a time. You're looking at the performance. You're looking at the mechanical features, the steering, the power of the vehicle itself. Kind of
Right.
the mechanical feature. While the electronic development was typically an outsourced solution that would be a cookie cutter installment with minor tweaks to multiple different OEMs.
Right.
And I go back to until something major happened. And I think what happened was the birth of electric vehicles, right? And it came the company of Tesla, right? And all of a sudden you think about a Tesla vehicle, which arguably, some could think that it's actually really not about the vehicle itself. It's about the piece of electronic software. And it changed it. All of a sudden, electronics, insourcing, and electronic development becoming a core competency of a major automotive company. And people started realizing, well, now it's maybe time for us to insource everything. Maybe it's time for us to go to market with infotainments being the center of attention.
Right. Right. Yeah, it was no longer about the engine and the transmission and whatnot. It was about the electronics and the battery and the efficiencies of the system. You're absolutely right.
Don't get me wrong, you still can go fast, right? It's still going to cost you some money, but I mean, you just look about the features and the volume of electronic componentry that needs to go into a vehicle, from sensors to semiconductor solutions, really into the system level development of electronics that can enable you to have self-driving vehicles, to have opportunities to capture, to connect to the internet within the vehicle, and just the sheer cameras and connections and censorship that goes into all of that is really incredible. And it is a differentiator. You think about that IoT evolution, and now, as of a couple of years ago, we started scratching surface with AI and large languages. And I just think we're on the brink of something incredible.
Yeah.
The next generation of how people will interact.
So when things started moving to the cloud, I mean, I know you were all part of that, with Altium. Was there a lot of trepidation, or were people scared of putting all of their design tools up in the cloud with potential IP and things like that being up there as well?
That's a really good question, Ray. And I lived through that, right? And had many conversations around such things. Really, it's a dual-sided answer. And arguably, one of the answers that I personally believe that AWS or Azure are safer than, holding things on-prem. And one could argue, and we can go, speak for an hour just about that. And not really going into the detail of security, but what we did see throughout the adoption of cloud in electronic development is that more companies are indeed migrating to the cloud. And why is that? It's not just magically that because people are wanting to be on the cloud versus on-prem.
Right.
I think it's just the natural evolution of where the industry is headed, right? And it's headed by AI power processes that we're going to be talking about today. But yeah, we definitely encountered a lot of conversations around, oh yeah, I'm scared my data is not going to be, safe on the cloud, or we are so used to the traditional ways of doing things, which is, having our on-prem server and keeping that data within our system. But what does that do to a company when it comes to evolution? It limits you.
Right. Yeah. I mean, you stay siloed and partitioned into your server or even your group server.
Absolutely. And you know how deep that can go from maybe some a little bit more flexible companies that are working in commercial applications versus going and drilling all the way down to mil-aero, right? Or government type organizations. And that's really where you start seeing things are just mandated by law for them to follow certain processes when it comes to serving their design development on-prem versus cloud. But even with such organizations, we're starting to see major pickups in cloud adoption.
I mean, I understand, why people would be hesitant to do that, but it seems like it offers so many more opportunities for advancement and collaboration that it just seems like a no-brainer.
Yeah, and another point to your previous question, I think, is the cloud adoption in our industry is actually pretty new. Right. So it's not that you're just trying to learn about benefits of adopting the cloud and what comes with that, but you also have to think about that it's only a few years old. Any major CAD tool that you can think about primarily served partners on prem solutions. I mean, it wasn't until maybe 3-4 years ago where you start really seeing the first launches of sophisticated industrial grade tools that served people through the cloud. And really, it's not that you're necessarily designing electronics in the cloud. The purpose of the cloud is really the enablement of efficiency.
Right.
You can still work on sophisticated industrial grade CAD tool, but then you can potentially export the designs. You can use tools like SnapMagic, that I'm a part of and a big believer in is because those things can connect to your CAD environment where you can collaborate, we can improve on efficiency, you can connect to different apps in the cloud, assign tasks, right? So that whole collaboration around the design itself happens in the cloud. And that's what the cloud today does. It connects apps and helps people communicate better without having them face the obstacles of just sitting on your machine and having to export everything and email it back and forth with your colleagues. And we all love emailing each other, right?
That's right. Okay, yeah, I'm going to email this file, take a look at it, and email it back.
But think about what happens is when you actually download something or you export something, and then you email it.
Right.
And then let's say you and I are emailing back and forth around a project. I can even step out of the electronic industry, right? Any type of job.
So any design, right?
You and I are emailing each other.
Right.
And then, we move on with our life, with our work. And then 3 weeks later, we have to go back to this. Well, where is this communication stored?
Mm-hmm.
You're going to have to pull up your design. I'm going to have to pull up my design. And then guess what? I have to pull up my Outlook or my Gmail. And then I have to find the thread that you and I communicate. So what happens is that the continuous thread and chain of communication is broken every time you and I send an email to each other, or you and I send a Teams or Slack message to each other, because there's no central place of storing a project data when it comes to the design itself. And I think this is the stage where our industry is really headed aggressively when it comes to the PCB design itself.
So being able to not only work in the same environment, but all the communication and all the issue resolutions and things like that, like you said, without breaking that communication chain. And it's interesting because a lot of people think, well, yeah, I'm communicating, I'm emailing. Email's communication. But to your point, it is, but it's not cohesive.
Exactly. Right? And I think that's the evolution. We've done the job, don't get me wrong. Right? We've all done the jobs and we designed fantastic products.
Oh, sure.
This is just a natural evolution of how electronic design works, right? And hence the adoption of the cloud. Imagine you're working within a centralized platform where not just you and your inner team of, let's say, designers are working on a project or co-designing things, but also working on with other teams, with mechanical designers, with simulation folks in a company, with supply chain people, with assigning work tasks and workflows within that design process, is going to be centralized.
That makes total sense.
We're going to continue to use different apps for communicating with each other, but what if those apps, and we see that today, all those apps are today connected, right? Oh, can I connect this app to my CRM? So, it's no news that we're logging emails into, CRM. Our industry has been a little bit slower to adapt to that, given the nature of on-prem solutions and traditional desktop libraries. But now you're going to start seeing those kind of centralized places of information and communication storing, or just from the core project management solutions, you're going to be able to enable all the stakeholders to see the project updates in one space.
And once again, that level of collaboration is something that even, like you said, just a few years ago isn't possible. You were saying, okay, I finished this particular layout. I'm going to email the file to the mechanical guy, and they're going to go do their thing and then email that back and to maybe to the thermal guy and, so on and so forth. You
nailed it, right? But again, doable. The problem that you might encounter is we might email, but there's a lost track record of who assigned the task, or do I need to do something, or does my colleague need to do something, or does the thermal guy need to do something? And it's again email, right? Versus here's your task, okay, it's in your assigned, comment back, push back, everything is centralized within that cloud application.
Any changes are automatically annotated, things like that. That would be fantastic.
Yeah, if you can imagine not having to export every time you make a change. And again, all of this evolution is in a context of designing electronics better, allowing the engineers to focus on what matters, which is really cranking out amazing new product developments. And saving them time, right? Less work on non-necessary repetitive tasks, more efficiency, better communication, centralization. Why? Again, people love saving time. People like getting more things done in less time. And I think really that's where we are today as an industry.
That's it for now. Stay tuned for the next episode as Nemanja and I dive deeper into specifics of AI-based engineering tools. Until then, explore more content from Mouser's Empowering Innovation Together series by visiting mouser.com/empowering-innovation.